Mistake or not, one of the most documented examples of nanoscience known in history is medieval stained glass artisans. They were the first nanotechnologists, as they, although unaware, trapped gold nanoparticles in the glass matrix in order to generate the ruby red color in the windows. They also trapped silver nanoparticles, which gave it a deep yellow color. Ceramicists are another example of the practice of the early forms of nanoscience. The people in Umbria, Italy during the Renaissance period, 1450 to 1600 AD, used nanoscience to produce iridescent or metallic glazes. The Lycurgus cup was made by the Romans around the 4th century AD. An interesting fact about the cup is that the colors of the cup can change. When it is looked at in reflected light or daylight, it appears green. However, when light is shown into the cup and transmitted through the glass, it changes color to red. Although nanoscience is a fairly new science, the chief concepts have been developing over the course of 50 years. Interestingly, we have been employing nanoscience for over 1,000 years, from painting to making steel. Although, what has changed recently is our ability to manipulate and engineer in the nanometer scale.
Previously, we rediscovered a world within ours, which is a billion times smaller but a billion times more miraculous, that is, the nano world. We began an epic journey, which we will continue today. Welcome back to the Nano Odyssey. Today, we will take another journey, a journey in time. It's time to learn about the history of the nano world. When mankind first realized that there is a hidden mechanism that governs nature, the most exciting new discovery was something we take for granted nowadays: making fire. Soon after, we began looking at stars and mapping our way across oceans, discovering more and more with each new voyage. When science was actually written down so that it may be safeguarded for future generations, the major limiting factor on the limits of our knowledge was the unavailability of proper equipment to create, recreate and confirm scientific hypotheses. But as we grew in knowledge and understanding, with the passage of millennia, we finally reached a point in time when we understood that matter was made up of fundamental units called atoms, and that they themselves were made up of several subdivisions of particulate components. Beginning in the 20th century and dominating science in the 21st century was a branch of science that allowed us to play with atoms like pieces of a jigsaw puzzle and create new wonders in science every day. That field was called nanoscience, or technology that is approximately 1,000 times smaller than the smallest microchip. While speaking at Caltech, Dr. Richard Feynman gave a lecture which he titled, "There's Plenty of Room at the Bottom," where he talked about the possibility of working with technology almost at the atomic levels. He talked about how we humans tend to want things that are more compact and yet more functional than whatever came before. In his time, computer chips which are almost a centimeter in size had just been developed. And yet, in his typical visionary worldview, he realized we could still do better, go smaller, and be even more ingenious. He said that as the sizes got smaller, one would have to redesign tools because the relative strength of various forces would change. Gravity would become less important, and forces between atoms would become dominant, affecting almost all the properties of these atomic arrangements. Feynman mentioned these scaling issues during his talk. He also dreamed of the high-tech sci-fi possibility of swallowing the doctor. This concept involved building a tiny swallow-able surgical robot, which is almost a sure certainty, considering current advances in the field of nanoscience. And mind you, he said all this way back in 1959, which over 60 years ago. The term nanotechnology itself was coined by a Japanese scientist named Norio Taniguchi of the Tokyo University of Science in a 1974 conference to describe processes exhibiting precise control on the order of a nanometer. His definition was, nanotechnology mainly consists of the processing of separation or deformation of materials by one atom or one molecule. Any ordinary computer chip or any small or integrated circuit typically has at least a few thousand smaller units called transistors, which are essential to the working of the system. In 1965, Gordon Moore, the CEO and co-founder of Intel, made a bold statement that in order for the limits of human technology to be pushed even higher, the number of transistors on a chip would almost double every year to allow more advanced functionalities. Initially, this statement was met with ridicule and laughter, but this seemingly outlandish statement has been turned into reality in the modern age, with bold strides in nanotechnology, allowing us to build faster, smarter and smaller technology. As time passed and technology became advanced enough to actually observe these nano-sized entities, focus shifted from simply making nanotechnology to actually doing nanoscience. Now that we had the tools like scanning electron microscopes, which enabled us to actually see what a structure or material looked like, transmission electron microscopes, which enabled us to obtain a sort of X-ray image of a material all the way through it, X-ray diffractometers, which let us observe the ordered arrangement of atoms in a nanomaterial, among many others, we could finally not only observe, but also manufacture and manipulate matter at the atomic level to make a dizzying number of new nanostructures and nanomaterials, with an equally staggering number of properties and potential applications. When we had built up a mountain of data to go through, it was time to actually study the unique electrical, magnetic, optical and physical properties that these novel materials and structures possessed. The new millennium saw the rise of the use of nanotechnology in commercial products. Examples include titanium dioxide and zinc oxide nanoparticles in sunscreen and cosmetics, silver nanoparticles in food packaging, clothing, and disinfectants, carbon nanotubes for stain-resistant textiles, and high-strength materials, cerium oxide as a fuel catalyst, among several hundred other applications. As of March 10, 2011, the Project on Emerging Nanotechnologies estimated that over 1,300 manufacturer-identified nanotech products are publicly available, with new ones hitting the market at a pace of 3-4 per week. Commercial nano device production began in the 2010s. In 2013, SK Hynix began commercial mass production of a 16-nanometer transistor, and Samsung Electronics began production of a 10-nanometer processor component. TSMC began production of a 7-nanometer process in 2017, and Samsung began production of a 5-nanometer process in 2018. In 2019, Samsung announced plans for the commercial production of a 3-nanometer GAAFET process by 2021. Friends, it is only when we realized how small we were in comparison to the size of the universe that we dared to dream beyond the stars. Now that we realize that there is another universe under the layer of reality that we see, it is just another adventure waiting to happen. Our Odyssey has only just begun and promises an enlightening journey ahead. As always, we must not forget that the things we think are impossible are nothing but dreams of the future. This is Mr. O signing off until we meet again on a journey into the unknown.
In the next episode, we will take a deep look into various approaches to design of nanomaterials and various sources of inspiration in nanoscience. Hey, I am Miss Keen. Thank you for watching. Don't forget to like, comment, share and subscribe to my channel. And for latest update hit the bell icon. Until then, keep exploring.